Okay, well, it's 5 o'clock. I'm Scott Grizzard. This is Calculus 1 quiz review for 4B. We are both on Twitch and Blackboard Collaborate Ultra. I'm from the University of South Florida. I forgot. Scott Grizzard, University of South Florida. We are in both on Twitch and in Blackboard Collaborate Ultra. You may ask me questions on Twitch chat over there. But remember that those are public and open to, everybody can see them. Or you can ask me questions in Blackboard Collaborate Ultra. Polling will be in Blackboard Collaborate Ultra. If you are watching in both places, let's turn on that. If you are watching in both places, reminder to turn off your sound in one of them, or you'll hear both. So in order to do that, what you're going to do is you're going to go over to Chrome, assuming you're watching on Chrome, and you're just going to right click and you're going to hit mute site on your Blackboard Collaborate Ultra or the other one, or on your Twitch if you're watching it on Twitch and listening on Blackboard Collaborate Ultra. I imagine it's out of sync if you're doing that, but okay. Just to remind everybody, the test is this Saturday. It is at 9 a.m. You have to be online at 9 a.m. That's when the test time will start. There's no it's open all day. No, it doesn't work like that. It's at 9 a.m. It starts. The test is supposed to be 75 minutes long. There's some built-in padding time there for dealing with grade scope issues or Proctorio issues. Now, remember that in the morning, like at 8:45, what you're going to want to do is log into Discord on your phone, because you can't log in on your computer because Proctorio is going to want your computer's microphone and camera. So what you're going to do is you're going to log onto Discord on your phone, and you're going to jump into a chat that'll be called something like test chat. And everybody will be muted in that except the person making announcements, either me or the TA. And then there will be a place called questions. Raise your hand or something like that, where you can raise your hand, where you can jump in that voice chat. And there'll be TAs. I'll be in there. There'll be a TA in there, and we'll help you with issues. So that way you'll hear any announcements. And that way, if you have a problem with your internet connection in the middle of the test, or you have a Proctorio issue in the middle of the test, you can contact one of us and we can help you deal with it. And get everything set. So the test is a Saturday. There's an announcement up with all of the current test review stuff, right? So, of course, there's a live test review on Discord tonight at 7. Another one at Thursday, tomorrow at 12:30. And a reminder, on Friday, there's no on-campus office hours, and my office hours are moved to 2 to 5. So I've made them longer. But twice as long, a little over twice as long. But because of the discrete test on Friday, I have to have virtual only office hours, and I can't do them in person. There's all these resources. If you've not checked out the official study guide, please do so. It's got a bunch of information about it has a bunch of information, review problems. It's got the list of the big problems from the quizzes. And then it's got problems for each section that's covered on the test, additional problems that you can work through, and additional examples that you should read. So there's all of those other things. So that's on Canvas. You can also, there's the bootleg, remember, is due Friday at 1. And then there's 2 extra credit web assigns review, and there's a peer leading review. Any questions? So there is peer leading on Friday, and that's also a test review. Okay. All right. So that's that. Let's get on into the quiz here. Oh, we do have a question. We have a couple questions. Yes, so it's not that you print out the test. There's going to be an answer sheet to, we have another, there's going to be an answer sheet that you print up in advance. and then you do and then the questions will be on a PDF, but you'll also have the answers, if that makes any sense, on you'll have an answer sheet where you fill everything out. Good question. Any other questions? So you'll find it as soon as I get it. I don't have it yet. We were supposed to have it earlier this week, but I don't have it yet. So as soon as I get it, probably Friday, maybe tomorrow, hopefully tomorrow, but maybe Friday, I will post it so that you can print it out in advance. Yeah, I'm not happy about the fact that the thing. And yes, we do have group work today. Any other questions about those things? Okay. So on with the quiz. Let's see. So the first question here was just to find the function. I asked it on 2 quizzes, so you might need it for the test. Maybe not. I don't know. But maybe. I did ask it twice. Any questions about that? So how do we feel 1 to 5 about that one? Oops. That's the wrong place. Polling. Multiple choice. Question 1. And I don't know how the question's phrased yet. I don't know if it'll be like that. It might be a true false. It could be something like that. Now I get the polling active. There we go. All right. Question 2 was about how to apply the binomial theorem. So if you are in discrete, by the way, and you're watching this video, you do have to know the discrete math. If you're in my class for discrete math, you actually do have to know the binomial theorem for the test on Friday. But if you're in calculus, you don't need to know it off the top of your head. If you needed it, it will be given. So calculus, you don't need to know it, but discrete math, if you're watching this, this is the calculus quiz review. So you still need it on Friday. All right, so what I'm going to do is I'm just going to take x plus 5. There we go. So what I'm going to do is I'm going to take x plus 5, x plus h to the 5th. I'm going to get 5, choose 0, x to the 5th, h to the 0, etc., etc., etc. I'm just going to sub into my formula. How do we feel about that, 1 to 5? Someone's asking if they're allowed to watch this if I'm not a student. Absolutely. Okay. All right. My cat is protesting the fact that she's inside. Do you have to write it in this notation? The notation, this 5 choose 0, 5 choose 1, 5 choose 2. I even said it. I wanted you to just leave it in those terms. Did you have to write it in this notation? I suppose not, but there was a reason I wanted you to do this. All right. The next one, I'm going to do f of x equals x cubed. And I'm going to use the definition of the derivative to prove f prime of x equals 3x. This is a popular type of question for things like the exam. But notice I give you the answer. Now, this is 2 things. 1, you can't use the power rule. You actually have to use the definition of the derivative. But the second thing is that it's easy to confuse which one is which. So when you're doing the sub, okay, be very careful. Let me show you what I mean. So I'm going to write what I want to show, and I'm going to write my strategy. I'm going to use the H definition, the binomial theorem, and the limit laws. So what I'm going to write is I'm going to write f prime of x equals the limit as h goes to 0, f of x plus h minus f of x all over h. And then what I'm going to do is I'm going to sub in for f. And this is the part where it's very easy to put 3x plus h squared in instead. So you want to be very careful because that's a common little error. That's annoying. You make it and then it throws off your whole problem. and you understood the problem very well, and you just made a stupid little mistake. So what I do when I see this problem is I write what f of x is on top, just to make sure I know what it is. And then I write what f of x plus h is. Just to make sure I'm looking at the right thing, because your eyes normally want to go there, and you don't want to do that. So that's just a little tip to keep you from making a silly mistake that costs you a bunch of points when it shouldn't. And the next thing I'm going to do, I'm going to keep going here. I'm going to go limit as h goes to 0, and I'm going to do my sub here. I'm going to do x plus h cubed minus x cubed all over h. All right. Okay. Well, now, of course, I'm going to sub in with the binomial theorem. Oops. I had some hitchhikers here. Like that, but you can't write the binomial theorem that quickly. And then what I'm going to do is I'm going to do the cancellation on the next step. So what I'm going to do is I'm going to use I told you what the things were equal to. And what I'm going to do then is I'm going to stick the cancellation step here. And that's the cancellation of the x cubes, right? So you go away here. These two terms are exactly the same. This is a 1. This is a 1. So this becomes x cubed. All I did was I fixed, I changed the binomials, which I gave you here. All right. So I wind up with that answer. Now what I'm going to do is I'm going to wind up factoring out an h and canceling it. And I'm left with only one term without an h in it. So at the end of the day, I'm left with this. So I'm just going to do, this is now a polynomial in terms of h. Not in terms of x, in terms of h, because these things are, x is fixed. Remember that. So all I'm going to do is I'm going to do a little direct substitution here, and I wind up with 3x squared plus 3x times 0 plus 0 squared, and that equals 3x squared. Right, and then I'll do a little tagline at the bottom. So f prime of x equals 3x squared QED. Okay. So how do we feel about that problem 1 to 5? So just remember, it's very easy to make a mistake right here. So don't do it. Warning. Don't do that. Don't use that. So how do we feel about that one 1 to 5 there? And don't get intimidated by this word prove. Notice this is the exact same thing that I have been doing the whole time. Right? This is the same thing I've been doing on WebAssign for today, yesterday. Right? All I'm doing is the only thing, when it said prove, don't let that intimidate you. And it could have said show. Right? It's the exact same problem. The only thing prove says is put some words in. Right? Strategy. Use the H definition. I just said what I was going to do. If this appears on the test, you'd wind up with either use the H definition. You could do this with the X to T definition. I'm sorry, T to X definition. That is actually on one of the problems on the bootleg gives you that hint with a difference of cubes. And you could have also done, there are a couple of, you could have used that definition and factored it. if this was x squared, which you've seen a lot. Okay. So don't let that word prove intimidate you. Now, what if it was something like this? What if it was something like, oops, let's get rid of all this. We don't need this stuff. We don't need this stuff. Okay. And we definitely don't need that stuff. What if it was something like this? Let's give another example. Prove if f of x, let f of x equal x squared minus x. Prove f prime of x equals 2x minus 1. So I would do the exact same thing here. Okay? So I would do the exact same process that I was doing before. I would say want to show, and then the limit as h goes to 0, f of x plus h minus f of x all over h equals 2x minus 1. Strategy, use h definition and limit laws. Now, the thing that's going to be a little bit trickier about this problem here is that now I've got this x squared plus 1. So the substitution's got to be a little harder. So I'm going to do that first. Okay? The first thing I'm going to do, as I said, it's very easy to accidentally use that one, and I don't want to. So what I'm going to do is I'm going to write up here, I'm going to write f of x equals x squared plus x, which means f of x plus h equals what? What is f of x plus h? All right. I'm going to take x plus h and sub it in every time I see x here. So f of x plus h is going to be x plus h squared minus x plus h. I need to be very careful there. Okay? So how do you feel about that substitution there? Okay? If that substitution's bothering you, come see me because I want to talk about it. Yeah. Oh, you're right. Did I? Oh, it should actually be minus here as well. I miscopied it when I did it here. That's my fault. All right, so now I've got this right here. This is going to be the tricky. If that's throwing you for a loop, if the sub is throwing you for a loop, here's a tip. So, for example, if I wanted to use a different variable, what I would do is I'd write f of a equals a squared minus a. So now I don't have an x floating around what I'm trying to apply by theorem. Or I can write this as f of a plus h minus f of a with f prime of a. The point is, what I'm going to do is I'm just going to change. If that's bothering you, just change your variable and it'll stop. It'll make your life better because you got an x here that's different from an x here. And that's annoying. Now when I do this, make sure that you are very careful about these signs and that sign there. So here's what I mean. I've got f f prime of x equals, now I'm going to do this, the limit as h goes to 0, f of x plus h minus f of x. And again, you don't need every step. So I could, especially since I said this here, I can just skip this and go straight to the substitution. I don't need every little step. Now, I already wrote this up here. X plus h squared minus x plus h. And now I've got another one. I've got minus and then all of f of x. So it's very easy to mess that up and forget that it's minus all of it. You have to remember your grouping. So there's if there's a whole bunch of little stupid mistakes you can make here. Okay, is everyone on board with that? That there are all these little stupid mistakes that you really just want to be really careful on these problems. And I hate that. I hate this kind of polynomial thing for that reason, but it always shows up. Because you could just make stupid mistakes. Even though if you understand the problem perfectly well, you make little stupid substitution mistakes, and that just stinks. Okay, so now I'm going to do this. It's going to be x squared plus 2xh plus h squared minus x, watch this, minus h minus x squared plus x all over h. If you get here and the things that you think need to cancel don't cancel, it's because you made a mistake somewhere translating this here. If you wind up with stuff that doesn't cancel, it's because you made a mistake in here. Now, that x squared is going to cancel that one. That negative x is going to cancel that one. And then I'm going to factor out the h. Everything left has an h in it. 2x plus h minus 1. Watch out. If you get to the end and you're missing like a 1 or a constant, go back and find that h. Cancel, cancel. And I wind up with, I directly substitute in, I wind up with this term going away right here, and it becomes 2x plus 0 minus 1, which equals 2x minus 1. So how do we feel about that particular, oops. Oh, no, I want my polling natural choice there. So how do we, that new example? How do we feel about that one, 1 to 5? So it's got a lot of little tricky bits in it, okay? So you just have to be, like, careful as heck. You have to be very careful with this problem. It's easy to lose that h because, look, it's trapped between two things that canceled. It's very easy to go a little bit too far with the cancel. It's very easy to forget one of these signs. You know, you can't see my what I'm pointing at all because I'm used to like using the docucam in the class, right? So I'm pointing to it. Of course, you can't see it when I point to it. It's very easy to forget that minus h there because you accidentally over cancel so that you stroke your pen a little bit too far when you're doing your canceling and you lose the h. It's very easy to think that this h becomes 0 by mistake. It's very easy to multiply through forget one of these negatives. It's very easy to make the mistake I just did up here where I miscopied the problem at the very beginning, which would have messed the whole thing up. So watch out for these because it's annoying when you mess up a problem like this, okay? And it doesn't come out. Now, here's a trick. If you mess it up, don't force it. Okay? What do I mean by that? What do I mean by don't force it if you mess it up? What I mean is continue on with your calculations. Okay? Okay? This is what I mean. Okay? If you think you've made a mistake, don't force it. Continue on if you cannot find your mistake. Obviously, if you can find your mistake, fix it. But if you can't find your mistake, continue on with your honest calculations. And then at the end, said you made an error, but you cannot find it. Now, you'll get more points because what will happen is that as the grader's going, the grader will spot your mistake, hopefully. But then is the grader, the way the rubrics work is if you make a small mistake here, but then the rest of your proof is correct given your mistake, you only lose like a point. Whereas if you try to force it, you're going to lose the point where you made your mistake, and then you're going to lose another point or a bunch of points where you tried to force it because what you had didn't follow from the above. Okay? And sometimes you even get like forgiveness points at the end, especially for problems where what you have doesn't make sense. I had this economics professor that had a great thing. If you make a small math error, right, and come up with a negative demand, or if you come up with negative 1,000 quantity as the optimal quantity, and because you made a small mistake, you get no points. This was his philosophy. However, if you say, yeah, this doesn't make sense, the answer should not be negative, then you only lose the point for your mistake, right? So the point is that if what you have doesn't make sense, acknowledge it, and don't try to force it. So how do we feel about that little piece of advice about test taking? Hopefully I will remember. I didn't remember to mention this this morning. Hopefully I will remember to mention it during the test review. Don't force it. If you make a mistake, continue with your honest work, and then acknowledge your mistake. So, so how do we feel about that? 1 to 5. What I'm saying is you'll get a lot more points if you just continue honestly than if you try to force it when it doesn't actually go. Okay. And that's why I did this example, because I want you to have that. I want you to bear that in mind when you're taking the test. It'll help you maximize your points. Okay. Whether or not I should be teaching you that is another issue. Teaching you to maximize your points, but okay, I'm doing it. It seems to be to yes, I should be encouraging you to learn and everything, and I'm now speaking philosophically, which I don't want to do, which I love to do, but I shouldn't be doing. But, at the end of the day, I hope to encourage you to learn math for its own sake, but you are also getting a grade, so you might actually care about the grade. So I will try to maximize your points if I can. Why doesn't this... It's doing it again. Oh, there it goes. I think there's probably grease or something on my hand. Pet dander. Okay. Question 4. So I've got a point, right? So I'm going to use the point slope formula for a line, okay? So I want a line. I'm going to do y minus y0 equals m times x minus x0, right? That's just the point slope formula for a line. Now, I have x naught is 2, right? I don't know where I am, but if I want to draw this, I can just like draw something where, f prime of 2 is 7. Okay, so something like this, where I've got f prime of 2 is 7. Okay, and the point is, I don't actually know what f is, but I don't care. The point is, what I want is the equation for this tangent line. Right, I should have done something where it was negative, right? So f is going to be something. Let's see. F is going to be something with a tangent line of 7. All right, so let's pretend that's 7 and not like something with a 1. It needs to be sharper, right? So it's going to have a tangent line of something like 7. And it's going to have, and that's going to be at x equals 2, y equals negative 3. Right, and its slope is m equals 7. And I've got, I don't actually care what the graph looks like, but we'll go ahead and, it looks something like this. Who cares? Right? F, don't actually know what F looks like. I don't care. What I want is this tangent line. Okay, so how do we feel about what that question is asking for, 1 to 5? How do we feel about what it wants? And, of course, if there are questions, please ask them. Okay. The tangent line is the thing I'm interested in. So I want the equation for that tangent line, which means I want the slope of I want the line passing through 2, negative 3 with a slope of 7. And the reason why I know the slope is because that's the derivative, right? And if I think about it, that makes sense, right? It's the change in the function. It's kind of the instantaneous change of the function. One way to think of it is, and we're actually going to think of it as this way, is it's like the linearization. It's the linear estimate, around this function. If I was going to like force the function to be a line, it's really the, it's the best guess given that information, which probably made it more confusing. So what I'm going to do is I'm just going to plug this into the point slope formula, and you could have used any of the following formulas, which were all legal, right? You could have used f of, so you could have used y equals, let's see, what is this one? You could have used y minus f of a equals, this one is in the book somewhere. I don't know where. F prime of a times x minus a, right? That's another formula for this thing. Which is the exact same thing, right? I mean, that's the point slope formula. You could have used, there's something called the linearization formula, which we'll get to, which is L of x, L a of x, if I'm using this, equals f prime of a times x minus a times plus f of a. All of these formulas work. This says, and we'll get into this in module 2. Linear, I can't spell anything today. That's what that says. That's the linearization of f at a. Any of those formulas would have worked. You wind up with this, y minus -3 equals 7 minus -2, and that's your final answer. If you want to simplify it, you don't have to, but if you felt so complied, I would rather you not simplify it. Remember my big spiel about that. I would rather you not simplify it, but if you wanted to, that's how you would do it. I need to put that in the rubric or the answer sheet because the grader's going to want it when she does your quiz. Okay. So what's the point of this problem? There's the point. Okay, well, the point is now obfuscated by the fact that it... Does the Mac do this? Like not scroll properly if you're not perfect on it? And does it keep... I hate that keyboard. Is there a way to make that keyboard go away permanently? Or like only when I ask for it, like require me to actually push a button on the thing? All right. So how do we feel about that problem and all my griping about it? Let's see, polling, multiple choice, yes. How do we feel about that problem, 1 to 5? I know I spent a long time griping about things. And I'm not even talking about presidential candidates. Okay. Again, if you have questions, I prefer it not simplified. Again, it goes back to that thing where I did like sine pi over 2. The better answer is, I'm sorry, not pi, sorry, sine pi over 4. You know, the better answer is really 1 over the square root of 2 or the square root of 1/2 because it actually tells you where it came from. If you give me this answer and don't mention this formula, you'll actually get more points than if you gave me this answer here. Because if you mentioned this answer, you're supposed to mention the formula and these kind of things. But if you give me this answer, you've actually kind of mentioned the formula, haven't you? That's the formula. Whereas if you give me this answer, I'm like, well, where did that come from? Right? So if the rubric had said you have to write the formula for the point sort formula for a line, you've written it. You know, you've got a good argument. Even if the grader took points away from you, you have a very good argument to come back and say, hey, Scott, I gave you the formula. I just did the subs already. Right? And you did. You gave me the formula. You just did the subs early, which is fine. This is a better answer. Okay. No, you don't need to move the y0 to the other side. You've given me, I didn't ask you for a function. If I had asked you for the linearization, you would have had to. But I didn't ask you that. I asked you for the equation of a line. The equation of a line is, well, this is an equation, right? Is y minus -3 equals 7 times x minus 2 an equation? Yes, it's an equation. Right? Now, if you gave it and then simplified, yes, you get full credit. But what I'm saying is, don't like skip to this, especially if you're using like one of these formulas. You need to, you know, if you use this formula, I know where it came from. If you just give me this, I'm like, what? If you give me this whole thing, right? If you gave me y equals this with the thing separated, you've actually kind of shown where it came from. I would want to take a point, but I would accept the argument, right? I would take, if you had given me this answer without saying this, if you had given me the answer on its own, y equals 7x minus 14 minus 3, I probably would have taken a point off for this. Again, alone, with no other work. If you had given me this answer, I probably would have taken a point off for this for communication. But if you had come back and argued it with me, I would have given you the point back. Because this actually tells me where it came from. 7x minus 17. Okay. And that's a real danger on the test with your calculator. That I'm actually for not allowing calculators on the test. In one sense, you're better off without it if you're going to make these mistakes. If you're going to make the mistake of just giving me the minus 17. Now, unfortunately, I didn't write the test, so I don't know what the math on it looks like in terms of computation. So it's a good thing that you're allowed a calculator. If I was writing the test and I was the only one doing it, I'd actually make it easy enough to do without a calculator, because I'd rather you tell me how you're thinking, if that makes any sense. But I don't know if the computations are easy enough to not use a calculator. And I'm speaking too much again. Okay. All right, let's go to this last one. All right, so this one's a little bit harder. Remember, I'm going to do this in 3 steps. Step 1, make notes and do fixed. I shouldn't use the word fixed, but I'm going to. So do points I already know. Step 2, connect. And I should put connect in quotes. From left to right. Step 3, verify. All right, so that's what I'm going to do. I'm going to do this in 3 different steps. Okay. So the first one, I think it's the button on this shirt. Okay. So this first one, this is -2 left, infinity. Now, I'm a little dyslexic. Like, really? I could get extra time on my test if I wasn't also very lazy and didn't want to fill out the paperwork. But when I do this, this -2 left, I sometimes mistake these for y's and these for x's if I don't do it like this. So what I do is I put the coordinate together, x, y. That's up to you whether or not you want to do it that way, but that's what I do. Okay, so these 2 are just points. I'm just going to go, dadgummit, stop that. I'm just going to put those on the graph. So there's that one. That's -2 left, infinity. -2, 3 is this one. Now, f prime of u equals 0. What does that mean? What does it mean to have a slope of 0? If a ski slope has a slope of 0, is it fun or not? It's not a very fun downhill skiing experience. You know, that's cross-country skiing, right? If the slope is flat, you know, it's not very fun. Right, so I'm just going to write flat here. This is just a note to myself. Maybe I'll write flat here. All right, -infinity, -2 is on the graph. So I'm just going to put that there, -infinity, -2. Now, what does this condition mean? What is that the definition of? The limit as x goes to u of f of x equals f of u. What is that the definition of? It's continuous. Right? That's the definition of continuity, right? Now, here's why that's important. I mean, besides the fact that it needs to be continuous there, I need the derivative not to exist. Now, how can I do that? What is the derivative? It's an atheistic, prudish, or a prudish atheistic white boy. But remember that right? Prudish atheistic white boy. Okay? He's atheistic. That means he doesn't like holy. Nothing infinite. And he's a white boy. He can't jump. And what's the thing about the prudish? He doesn't like things that are kinky. This is the derivative. Now, these things, if I jump or I have something holy, I'm going to create something that is discontinuous, right? So I can't do this and I can't do this. The only thing left I can do is a kink. So I'm going to draw a little arrow here. I'm going to write kinky here. Okay, so how do we feel about that, 1 to 5, interpreting the conditions? How do we feel about what those things say, and kind of how do I write down, make my little notes? I interpret the conditions, and I make a couple notes. Right. To which I think that, a comedian's offensive, but is he funny? I think personally that if you say something inappropriate in a class, but everyone remembers the concept, you should be able to get away with it. There's there should be a scale, right? Inappropriateness, memorability. There's kind of a scale there, right? There's kind of a trade-off. Okay. So now what I'm going to do is step 2. I'm going to connect from left to right. Okay. So let's do this. Connect the dots, la 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 la. Now let me use the pencil. One thing I really like about these videos is I can actually show you process instead of just giving you the answer key at the end. The video, by giving you a video that you can go back to, you can actually see the process again, right? There's more how to it than just giving you the answer key. Okay. So I'm going to connect those two kind of like that, right? So I got a nice flat line here, there. I mean, not flat. I got a nice little kind of root that goes up there. Now it's got to be flat here. So I'll just draw a nice little flat line. All right, and then I come to this point where I need a kink. Well, I'll just give it a little kink. And notice there aren't any other conditions except continuity, right? I don't have a positive infinity, so it doesn't matter what my function does after this, as long as it's defined and continuous. And then, because this might not be obvious that it's sharp, I'm actually just going to write kinky. Or corner or cusp or something boring like that. So how do we feel about step 2 there? So let's get rid of step 1 and let's do start. So a kink, so like a hose, right? If I take a hose and I kink it, the water can't flow. In Southern, it's called kink. I understand this is called doing something else if you're a Yankee, but with a hose. Or is it called kinky still if you're north of the Mason-Dixon line? I don't know. So it means it's got a corner, right? It means that the derivative for the left, I don't really have a tangent line here, do I? Because this is a sharp corner, right? From this direction, it's 0. From this direction, it's negative 1.5-ish, right? Yeah, negative 1.5-ish. But here, I don't really have a tangent line, right? Because, the line tangent to the graph, there's like a lot of them I could pick. So it's not really defined, right? It could be this, right? There is a tangent line there is a derivative to the left, and there is a derivative from the right, but there's no like derivative in the middle. Oops. Because kind of everything here would work. Does that make sense? All right. I'm eating up all your time. And I'm sorry about that. Okay. Yeah, they gotta that's another way to think of it, right? You got a kind of instantaneous change in the slope. And it's not just instantaneous, it's, sudden. Okay. All right. And then what I'm going to do is I'm going to check. So step 3, verify. Is it the case that the limit as x goes to negative 2 from the left is infinity? Yes. Is it the case that f of negative 2 is 3? Yes. Is it the case that f prime of u equals 0? Yes. Is it the case that u to negative infinity is negative 2? Yes. As x goes to u, f of x goes to f of u for everything in here? Yes. Yes. F prime of 1 does not exist? Yes. Okay, so I'm good. All right. A was this idea that negative 2 infinity is on the graph, right? The limit as I go to negative 2 from the left is infinity. Means as I go toward negative 2 from the left in x space, y space is shooting off to infinity. And I'd probably even do that. I'd probably write a little asymptote thing here. I'd do that. I've got an asymptote here, so I'll probably do that. I don't have to. Not required. Any other questions? Okay.